Hello, everybody. Happy Tuesday. Hope everyone is having a wonderful day so far. Welcome, everyone, to Red Planet Live. I am your host, Ashton Zeth. I'm elated to be hosting the Mars Society's podcast and leading the conversation about human exploration of the universe and the future settlement of Mars. As a longtime space enthusiast, I am passionate about STEM education and making humanity an interplanetary species. So thank you again, everyone, for joining us today and supporting the Red Planet Live. Today's episode features a renowned planetary scientist and a former chief scientist of NASA with 42 years of experience, known for his contributions in the study of planetary atmospheres and numerous missions under his leadership, including New Horizons spacecraft flyby of Pluto, the Messenger spacecraft to Mercury, and overseeing the landing of Curiosity rover on Mars. He's a strong advocate for science education and public engagement, and his leadership has helped shape NASA's vision for future space exploration. Dr. James Green, welcome to the podcast. Thank you for being here today.
Thanks so very much, Ashley.
I'm excited to be chatting with you. I talked this up with all my friends and family and colleagues, and so I know we have a bunch of them listening, and like I said, I'm really excited to chat with you today.
That's great.
Well, before we kick off the conversation with James, I have two special Mars Society announcements to share. The first is that the Mars Society recently announced the first cadre of 35 Mars Society ambassadors who have been formally accepted into the program. These ambassadors are a group of professionals and advocates who are committed to raising public awareness about the importance of exploring and ultimately settling Mars. The program is led by James Melton, a former journalist, college instructor, and professional pilot who now delivers keynote speeches and lectures worldwide on leadership, relationships, and the future. This group of 35 ambassadors consists of individuals from a wide range of backgrounds, including education, science, nonprofit work, and business, and are all from a variety of countries and cultures. In addition, the group includes many people of different age groups, from students who are currently enrolled in higher education programs, up to individuals who are active and hopefully enjoying retirement. The diversity of these ambassadors ensures that they bring an array of perspectives and expertise to their advocacy work. Over the course of their tenure as Mars Society ambassadors, the group will work together to promote the importance of human exploration and settlement of Mars. They will share their knowledge and insights through a variety of channels, including public speaking engagements, social media, and other forms of outreach. The program is expected to expand in the coming year with additional ambassadors being added to the group. For more information and to apply, visit marssociety.org. Congratulations to the new Mars Society ambassadors. Don't forget to wear your patch. And the second announcement that I have for Mars Society is that the Mars Society is thrilled to announce that their 26th annual International Mars Society Convention will take place this year from October 5th to 8th at Arizona State University in Tempe. This 4-day event will bring together leading scientists, policymakers, commercial space executives, government representatives, media, and space enthusiasts to discuss pressing topics related to space exploration, technology advances, and planning for human exploration and settlement of Mars. Now, to ensure maximum participation, the Mars Society will employ innovative technology platforms for in-person and virtual presentations, panel discussions, and debates. Attendees from around the world can join the conference, post questions, and interact with each other. Further details about the event, such as registration, information, a list of confirmed speakers, suggested hotel accommodations, and requirements for the poster contest will be released soon. Get ready to explore Mars with the Mars Society and stay tuned for more updates. All right, James, are we ready?
Yes, but you have to call me Jim.
Jim, okay. We'll keep it casual, Jim, as you requested. That's what I refer to. So on the Red Planet Live, I do a segment called Question of the Day. Mm-hmm. I know this particular question is going to be a heated debate, and I'm curious to see what everybody votes online. So make sure to put your answer in the chat, which should be on one of your sides here. So today's question of the day is, are you more of a Star Wars or a Star Trek fan? What do we think here? I know it's a heated debate every time it comes up. What do you think?
Oh, should I answer it?
What is your preference? Are you more a Star Wars or Star Trek person?
All right. Well, I saw the original Star Trek from the first episode, and it was really a change in a major way. In the 60s, it was cowboy shows, half gun will travel, riflemen, everything you can imagine, and then all of a sudden you're taken into space. You visit planets. You look for M-class planets so you can breathe on the surface. And so it was really to me the seminal change in the normal culture going on. And so I think that's what I would say would be my favorite because of that. It's also a time when we were moving towards that went on from 66 to 69. It was also a time when we were moving towards putting humans on the moon. So it really I think sparked a lot of what's going on. Now, not taking much away from Star Wars, that just kept the momentum going, but for a different group, a different age group.
Yeah. For sure. I agree with you completely. I do recognize that the significant impact that Star Wars made on film and pop culture and sci-fi. But personally, I do prefer Star Trek, specifically Next Generation. If you haven't had a chance to watch it, the new Picard series on Paramount is really good.
Okay.
So subtle plug there for the new series. I would also say Star Trek over Star Wars.
Well, Janeway was pretty neat too, and Seven of Nine. I mean, I had an opportunity to meet Seven of Nine. Jerry Ryan came to Goddard Space Flight Center during an outreach activity in the 90s, and I was head of the National Space Science Data Center, and she was taking a variety of tours, and I was on the tour. She came over to the organization. We had an opportunity to talk about some of the satellites that we're doing. And that was really delightful. She was really into, and I'm sure she still is, outreach, particularly for young women and girls. They're just a wonderful role model of getting involved. That I had an opportunity to meet her, but I also met Uhura. She had an opportunity to come to the Grail launch. Now, Grail is a lunar mission. It's 2 spacecraft that actually monitor the distance between the 2 of them, that orbited the moon, and they would move between the 2, attracted by gravity underneath them. And after 90 days, you get a complete view of what's inside the moon based on gravitational interactions of these 2 spacecraft. And she went to that. She gave 5 interviews. She was absolutely fantastic. She signed pictures for free. If you go to a Star Trek convention, you probably pay $20 per picture to get her to sign something. But here she did it for free, and the line went out the building and around. I mean, and she was there for 2 hours signing pictures. I mean, just wonderful people like that. Another enormously important role model. I mean, really important. She was quite seminal, as you probably know, for not only representing women, of course, but Black young women involved in top shows in that time period was a rarity. So, and she was just delightful. Just really wonderful person to interact with.
Yeah, absolutely. There's so many stories about her cultural impact and how she influenced film and TV, being a woman, like you said, African American woman on TV, and the impact that had. So yeah, I would agree for sure. I think that the chat is overwhelmingly Star Trek, so I'm glad to know that we have other Trekkies among us.
Well, they're both wonderful. I enjoy science fiction. You have to be able to dream and think about the future if you're ever going to have a future. This is, like seminal things that along the way that have happened, like the Andy Weir's books on not only The Martian, but Artemis, and now Hail Mary.
I'm reading
And
that right now.
yeah, well, okay, good.
Yeah.
Yeah,
Robert Hail Mary. Okay,
well,
admittedly,
no
I'm not
spoilers,
too
no
far yet.
spoilers.
Just started. I
Good.
bought it for my flight to Florida to go to Kennedy Space Center last week. So,
Uh-huh.
I'm not too far in it yet. So yeah,
Okay.
don't spoil anything for me. But
No
I'm excited about it, and that's pretty cool. I mean, you have a special connection there.
I do.
Contributed a little bit. To what level you
I
can
did.
tell us to The Martian?
I will. What happened one day is Ridley Scott decided he needed an expert on Mars since he now was going to produce the movie. The script was already written by Drew Goddard. It was Ridley really loved it, and he called up NASA headquarters and he said, "I want to talk to somebody that knows something about Mars." Okay. Now, as head of planetary, I had 3 branches in my organization. One was a research and analysis group. Another one was solar system missions that were discovery and new frontiers. But then I had a Mars branch. And the head of the Mars branch, we commonly referred to as the Mars Czar. And Chiwetel Ejiofor really plays that person in the movie.
Mm-hmm.
And that's the person that looks at all the robotic missions, interacts with JPL in terms of their management, how they're tasked, how they coordinate communication off the surface. All the stuff you basically see in the movie, that's run out of the Mars program. Well, Doug McQuiston was that person. He retired after the successful landing of Curiosity. And so I was acting in that role. So then that interaction with Ridley Scott fell to me. Okay.
Kind of landed in your lap.
Just landed in my lap. So I had a chance to talk to Ridley and his team for almost an hour. And they wanted to talk about a whole variety of issues from what is Mars really like? What is ion engines, spacesuits, all kinds of stuff. And I had a blast talking to him, but I said, okay, what we need to do is we need to get you to these places. We need to organize a trip to Johnson Space Center so you can see what Mars habitats we're thinking about, Mars vehicles we're thinking about. You need to get to JPL so you can see how we manage the robotic spacecraft.
Mm-hmm.
And and so let me organize that and get back to you. So that was the end of the conversation. But before it was over, they'd already sent me the script. So this was like on a Wednesday.
Mm-hmm.
So I hadn't read the book. They asked me if I had read the book, and I hadn't read the book at the time. So I got an ebook, read that and the script. And then on Monday, we had a major meeting in the Office of Communication at NASA headquarters, and they turned to me and said, well, what do you think? Should we support this movie? Should NASA provide some sort of capabilities and consulting with Ridley? And I said, absolutely, we need to do whatever Ridley wants, because he wants to make it as realistic as possible. The look, the feel, what is really going to hold the attention of the audience. That in addition to the script and the book. So they said, go for it. You're going to lead it. And as if I didn't have enough to do. So I also led that, and how we did it was I gave them the tours, and that was great. Then we had questions that were coming in every week. And so I'd go through the questions, and there'd be some I'd answer, and then some I'd farm out to other people to answer. And then we just kept doing that for several months. And then all of a sudden, silence. Now they're really going out doing it. And then I had an opportunity to go to the premiere, which was at the Toronto Film Festival. So it was great fun. And I think Ridley did a fabulous job. making it as realistic as possible with our help.
Yeah. Jim, I have to admit, this is kind of a full circle moment for myself. Often when I watch space movies, not that I'm an expert, but I'm always picking apart like, oh, that's not real. That wouldn't actually happen. So I appreciate that, they connected with you and you provided the insights to, keep the scientific integrity of the movie. People want to believe that this is real.
Sure.
And if, they can immediately identify some holes in that plot and this is not realistic, you might lose some of those believers, but if they feel inspired, hey, this could actually happen, you've got fans for life. So I appreciate that you wanted to keep it as real as possible by providing those insights.
Well, I'm a little different, although I really wanted this movie to be what Ridley wanted, which was realistic. Right. And I think we did a fabulous job of that. He really led that, and we supported him. But, when I go to any science fiction movie, I'd leave my science at the door, grab some popcorn and go in and just just enjoy it and let it be what it is. And I'm really not too critical about science fiction movies as they come up. But The Martian is certainly one of my favorites. That has to be right up there.
Yeah, I would agree with you there. Are there other space movies? I mean, you said Martian is right up there. What are some of your
2001? I mean, in '68, here's Star Trek. We were just talking about that, and now we're going to the moon. And now 2001 hits the screen. And even though as I walked out of the movie, I thought, what the heck did I just see? What did it all mean? And I had to figure it out for myself, as Arthur C. Clarke wanted us to. But the bottom line is that was a fabulous era. Just that decade, the latter part of the '60s into the '70s, was fantastic. I was in high school, I graduated in '69. And then went to the University of Iowa, and I ended up working in an observatory. I had a 12-inch Alvin Clark refractor at my beck and call. This was the year that Mars had a close approach to the Earth. Mars's orbit is elliptical, and we sight up to the area sometimes when we're real close to it, like 32 million miles away. And so I took a whole series of images. I built an instrument that had a camera body connected to the telescope, did all sorts of astrophotography, developed it myself, submitted it, got some things in Sky and Telescope, even published in Sky and Telescope. So, when I went to the University of Iowa, I knew exactly what I wanted to do, and that is get involved in space. And that was just the perfect place. Van Allen was there. James Van Allen, our first, truly creative and wonderful space scientist that discovered the Van Allen radiation belts. And I stayed there, got my undergraduate, master's, and PhD there. It was fantastic.
So after that, walk us through what you did after that. You got your PhD. Yeah. How did you end up at NASA?
Well, my PhD. My master's and PhD thesis advisor, Don Gurnett, which was one of Van Allen's early students, his philosophy was I could go anywhere I wanted to and give a talk about the research I was doing. And so I was giving like 3 talks a year at AGU and at special conferences. And I did that in my master's and my PhD. So that was 6 years, 3 years master's, 3 years PhD. So when I got my degree, I actually was pretty well known. I had already published several papers. One of which, one of the first ones I did is highly cited because it's an early set of observations on a very important phenomena about the Earth. It's called auroral kilometric radiation. It's the radio waves that are generated just above aurora. And from Jupiter, they're called the decametric emissions, but here at Earth, they're kilometric emissions. And so we observe that from space, can't see it from the ground. And so I had 5 job offers, and I picked becoming a civil servant at Marshall Space Flight Center. And so in 1980, I showed up and got busy analyzing data from Dynamics Explorer, in addition to the Voyagers. I was still working with Don Gurnett on and several others, Doug Minetti and others, on analyzing Voyager data, Voyager 1 and 2.
Mm-hmm. And then, 42 years with NASA and, like I said, oversaw quite a few missions. I have a ton of questions about, the various projects and missions that you helped with at NASA, but I want to make sure that I call this out as well. For those that are tuning in and listening, if you have any questions, please put them in the chat. I will be sure to sprinkle those through the questions that I have prepared for Jim, but I want to be able to ask your questions as well. So thinking of NASA and its missions, I was really curious to hear your perspective on Artemis. Obviously, NASA, Artemis recently had its successful launch, sending rocket to the moon and returning. And NASA just announced the next 4 astronauts that will be returning to the moon, including first woman and person of color. So for those that are listening, tell us why it's important to return to the moon. What are the scientific benefits? What will astronauts do when they get there?
This is really an exciting era, because in the last 10 years, we've really discovered things about the moon that we didn't realize for decades. The Apollo missions brought back some spectacular set of samples, but those are largely in mid-latitudes to low latitudes and nothing from the poles. What we're finding now is that what's in the poles, particularly in these permanently shadowed areas where the sun doesn't shine, is some really spectacular volatiles. Now, to understand that, you have to recognize the origin of the moon and the Earth comes from a theory that now looks like it's pretty solid. It's called the giant impact hypothesis, whereas the Earth was being formed, a proto-Earth, and other objects in the solar system. Another object called Theia, the size of Mars, was also in and around our orbit, hit the Earth. And so when the two of them settled down after this massive collision, you end up with the Earth and the moon. And the moon is about 4 Earth radii away. It's just outside the Roche limit. And so inside the Roche limit, where there's still debris, all that falls on the planet, just like the rings of Saturn are falling on the Saturn planet. And so now the moon over time is going to gradually move away from the Earth. We also found out that the moon during this time period generated its own magnetic field. So the magnetic field of the Earth and the moon began to interconnect. And this provides early Earth atmosphere to the poles of the moon. We also find out that during the time period called the late heavy bombardment, where we think the Jupiter and Uranus and Neptune and Saturn rearranged themselves a little bit. Perhaps there was another planet in the way there too. We don't know. That caused a major influx of asteroids and perhaps other objects, perhaps comets and things, maybe even Kuiper Belt objects. Certainly Kuiper Belt objects moved into the asteroid belt. We think Ceres is a Kuiper Belt object, for instance. Those volatiles hammered the moon, blowing away huge pieces of the crust, allowing the lower crust upper mantle material to flow in and create the dark areas that we call mare, but it also creates the outgassing that comes with volcanoes. And that means the moon had an atmosphere. Yeah. So this atmosphere comes when the moon had a magnetosphere. And indeed, what happens during this time period is the magnetosphere protects that atmosphere a little bit, allows it to live a little longer. The current estimates are that the magnetosphere protected the lunar atmosphere for at least a couple 100 million years. And what happens during this time period is that those volatiles then would migrate to the poles. The atmospheric pressure is twice that of Mars today, about 12 millibar, 10 to 12 millibar. And so you can imagine that the snowing out of these volatiles on the polar regions of the moon are also laying in these permanently shadowed regions. So the bottom line is, when we go in there to get access to water, we know there's water in there. That has come from comets. It has come from the Earth. It has come from meteorites. It has come from the moon itself over the several billion year history of these deposits flowing into the polar region. So the history of those interactions is laying in these permanently shadowed regions. So we want to core those. Now, they may be mixed up due to micrometeors hitting the environment, but we should get a general sense of what was going on over the history of the Earth and Moon. So this is just opens up a huge area for us to be able to study by going in there and getting the samples, let alone using those using the water that comes from that and other volatiles. You know, CO2 is probably in there too, and perhaps in abundance, and extracting the oxygen and being able to use that. Of course, for the water, we want to drink it. H2O is H2O, whether it's here on Earth or it's on the moon or on Mars, is water. And of course, you can tease it apart and create rocket fuel, or you can breathe the O2. So the water, it provides just a tremendous resource. All that was completely unknown in the 60s, in the 70s, in the 80s, in the 90s, and part of the early 2000s. And it wasn't until those last 10 to 15 years that we really started piecing together a new story about what really is happening in the polar areas of the moon. And that's where we're going to go visit. That's what makes Artemis, to me, a tremendously important set of missions and goals. Scientifically, it'll be spectacular. It will be a boon to our understanding of what's going on, in addition to being able to learn to live and work on a planetary surface, which we want to do before we go to Mars.
Yeah, that was going to be my next question, is how is the Artemis missions and going back to the moon is going to prepare us for the future, sending humans to Mars and the eventual settlement of Mars?
Sure. Well, being able to live off the land, ISRU, is really what we want to do. In situ resource utilization, ISRU. And that means if there's resources there, we want to use them. Okay, so if there's water in the permanently trapped or shadowed regions, trapped in these craters, and we get access to it, we're going to drink it, we're going to use it. Those processes of how to be able to tease that stuff out, how to melt it, how to utilize it in the ways I had just mentioned, to drinking, breathing, and rocket fuel, are processes we want to be able to test and use, and then do that indeed on Mars itself. Now, of course, we've started that process a little bit with Percy. Perseverance has a really nice experiment, MOXIE, which is designed to bring in the Mars atmosphere, zap that CO2, popping off an oxygen. And then, of course, free oxygen loves to connect and create O2, which then is breathable. And then you have CO, you end up with carbon monoxide and oxygen in the experiment. You vent the carbon monoxide, and now you got a ready source of oxygen to breathe. That's the oxygenator from the Martian, okay, if you will. And it's a great little unit, and it's working perfectly. It's doing astounding things, and in fact, that can be scaled. And if it's scaled, then you could set it down on the surface, and it can make a rocket fuel before you even show up, as an example. But Mars has also some spectacular resources. What many may not realize is with our radars on Mars Express and SHARAD on the Mars Reconnaissance Orbiter, that we have teased out a particular area on Mars, which is the old North Pole. Now, the Mars tilt, its axis of tilt is 23 degrees at the moment, but it can be as low as 15, but as high as more than 45 degrees. And so it just flips all over the place.
Mm-hmm.
And that means then the polar cap migrates. And indeed, we believe we have found the location of one of the old North Poles, and it has a considerable amount of water, ice. I mean, we believe it's about the size of the state of Arizona. It can be 750 meters deep in some places. And so I think the best places to be able to land and live on Mars will be in one of these areas that connects into this ancient North Pole, this glacier, this buried glacier. Now, in some places, it's not very buried, very deep, maybe under a handful of meters of soils and regolith and dust that you then can go in and bring in the ice, and that's far better than trying to extract it, I think, out of some of the other sources, the minerals and the and other sources. If it's readily available, let's just go do it. Mars has an enormous amount of water. It's just primarily in ice form.
Yep. Trying to extract it. Yeah, one of the things that I heard you say before was disruptive technologies.
Yes.
So I'm curious, what, in your experience, what are some of those disruptive technologies, and what disruptive technologies do we need to get us to Mars?
Okay. In my career, there's been a bunch of them. In 1980, I had an opportunity to start NASA's first internet. Now, we take internet for granted, but I got news for you. Prior to that, if you wanted to talk to somebody, you picked up a phone, which was connected to the wall by a cord, by the way, and or you sent them a fax or a telex. It's not like it is today, where it's email and it's all kinds of applications, remote logon, running supercomputers. That was a tremendously disruptive technology. And then, of course, in the 1990s, the World Wide Web came along, providing access to data. And now we're motivated because we have tools to be able to provide data to users in real time. As I mentioned, I was head of the National Space Science Data Center. Mm-hmm. And one of the reasons why I got the job is I had already supported and built a good chunk of NASA's first internet, and now I had the opportunity to put the National Space Science Data Center online. And so we brought a big terabyte worth of data, which was huge at the time,
right,
online. I mean, I got 4 terabytes in my Mac sitting in front of me, and that had all the IUE data, International Ultraviolet Explorer. We had also IRAS data, and we had all kinds of heliophysics missions and all kinds of stuff like that. And that data, you just log on and go get it. And that was tremendously important because the World Wide Web provided that interface that allowed you to get access to the data that you're putting online. Mm-hmm. Well, currently, and a couple beautiful disruptive technologies are right staring us right in the face, and we're using them like crazy, and we're going to do more of it. And that is, of course, the metaverse and AI. Artificial intelligence, in my opinion, is something we need to embrace. We need to use it. We need to understand where it's good and where it isn't good in terms of relying on the information we receive. Information literacy is so important. Yeah. We have to teach that. We have to teach analytical thinking more. And these kind of technologies are really critical for us to be able to, I think, bring in and use. So I think we'll see many more applications for those two in particular over the next couple of years.
Yeah, for sure. No, I agree with you there. And I was just watching an interview with Elon Musk talking about AI and the potential of it, but also some potential necessary regulations. So sure. That's an interesting topic as well. But I want to make sure. Oh, go ahead.
Yeah, I was just going to say NASA has a working group, and this working group's been going at least a year now on the ethical uses of AI. Okay.
Okay.
So they're working really hard to discuss how AI is going to be used in the agency, perhaps some of the ground rules. I mean,
Hmm.
Chat GPT, as an example of
Yeah.
here's a model on how information is brought in, analyzed, and then spit back out. Publishing what that model is, getting
Hmm.
people to comment on it, understanding the results that you get out. I've used Chat GPT a bunch in a variety of ways. For instance, there's been a number of really important papers that have come out by Chinese scientists in in Chinese journals. Well, I'm
Hmm.
not good in Chinese. My languages are Fortran and C++. And if it's anything other than that, it's not going to happen. Okay. And so I just take the paper, which you can, it's free. You PDF it, and then you feed it in Chat GPT, and it translates it for you.
Hmm.
I mean, this is fantastic in the sense that you get a sense for what the scientists are saying, and some of the translation might be off, but you really get a good idea what's happening. And that's just one of a gazillion ideas that people are coming up with really fabulous uses of AI. But I can also ask it a variety of questions for which there's quite a bit of scientific literature that have been accomplished, and it will come back with the wrong answer.
Hmm.
And then when you ask it, well, what references did you use to create that answer? Okay. It will come back and make up some references. I mean, it gives you DOIs that don't even exist. So you really have to know what's happening in the state of the art right now to be able to use this kind of technology. But it's going to be really important.
Yeah, absolutely. No, I agree with you there. Speaking of the Chinese papers and the publications around their science, I did have a question specifically about China, who
Uh-huh.
has clearly become a major spacefaring nation,
Mhm.
having sent rovers to the moon and Mars, and is looking to send future satellites and rovers. A lot of people feel that there is a new space race now. What are your thoughts on that? And do you feel like the U.S. and China could eventually cooperate on exploring space?
Well, the US and Russia, okay, was the
Yes.
Soviet Union,
Mhm.
cooperated even in the 70s,
Trying to
where the
mhm.
Soyuz and Apollo connected. And, there, space has been viewed, certainly being laid out in the Outer Space Treaty, with the foundation of space not being a hostile place, but being a place of cooperation internationally. And Space Station is a fabulous example of that. We want to embrace that. Now, China and Russia have the opportunity to get involved with some of the NASA activity through
Mhm.
the Artemis Accords.
Yeah.
They indeed could connect to NASA and say, we'd like to sign the Artemis Accords, and NASA would be delighted to let that happen. And right now, there's on the order of at least 25 countries that have signed the Artemis Accords. And we were just talking about going to the moon. The
Mhm.
differences, of course, are many. ISRU was one that we talked about, but how we're going back to the moon is the other. With the Apollo, it was a U.S. only activity,
Right.
and now when we go back, we really want to go back in an international way, where we have uh, uh, you know, uh, we have a Canadian astronaut in
Yeah.
the upcoming mission,
Mhm.
and so the Artemis 3 is more than likely going to have also international astronauts involved in that too. But we want to work together in a coordinated way, and I think the Artemis Accords lay out a really good opportunity for nations to participate and be part of, I think, one of this generation's greatest achievements, and going back to the moon, and really teasing out what's happening, living and working on a planetary surface, not a little sortie like the Apollos where you're there for a day or two and you're home,
Right.
but stay there weeks, months perhaps,
Mhm.
and really use the environment, as it's meant to, from our perspective, is a platform for observation. We can study the cosmos there. We can study the history of the solar wind is laying in the regolith that you're walking on. Okay, how can we tease it out? What's the history of our sun been like? That has allowed life to flourish on this planet, but not on Venus, or and so some of these really important questions could be answered by that vantage point of going to the moon and really staying there for long periods of time.
Yeah, no, absolutely. I think right now is a pivotal, an incredible time for the next generation, inspiring, obviously, young people to be involved in STEM, have future careers in science and engineering and technology, mathematics, obviously. But it will be interesting to see, the next, like you said, Artemis 3, which members of perhaps the European Space Agency may be included on that crew. To have long duration stays on the moon, similar to, astronaut Scott Kelly, when he spent a year on the space station.
Yeah.
I want to see something like that on the surface of the moon as well.
That'd be great. Let's do that.
Yeah. All right. We're in. Let's do it.
Let's do it. What's the hold up?
I want to take some questions from the audience. We have some great questions. Let's see. The first one that I'm going to read here is, when do you estimate that nuclear thermal propulsion technology could be used for future NASA crewed missions to Mars? And that's from Thomas Cleveland.
It's going to be a while, but there could be some major breakthroughs that happen. It starts, of course, with NASA working with the Department of Energy. Now, we do work with Department of Energy a lot. When I was head of planetary, Department of Energy managed a small amount of plutonium that came from the Cold War era of making nuclear material for bombs, and it was a product of that. It's not bomb grade anything, but plutonium-238 is just the right isotope, and we had a small amount, and that meant, well, what about missions like Percy? Where are we going to get the material to have other robots on Mars, or even going out to Uranus and Neptune, where the sun is very dim and solar panels are not going to cut it. So I worked with the administration at the time to restart plutonium production, and we came up with a way to do it. So I know we're working with Department of Energy is really critical, and they're so talented in many ways. That they created a process completely separate from what was done in the past to create plutonium-238, and now they're doing it on a regular basis. And that means the planetary missions of the future will survive in going to the places where the sun doesn't shine very much. I mean, even if you wanted a sample from Mercury, you'd get it on the night side. You'd probably use radioisotope power to power your systems, go down and get your sample, and then come off. You wouldn't get it on the day side. It's too darn hot. Mm-hmm. So, and the infrastructure to do that's too hard. So all that kind of stuff, and that includes, power even on the moon, is a new relationship with the Department of Energy that NASA has, and that research is going on. I'm not up on where they are right now in terms of what their plans are to be able to get these systems up and running. Mm-hmm. But my bet is it's going to take a while. So I think our first set of missions to Mars will probably be pretty traditional. Mm-hmm. Yep.
I hear you. Well, speaking of missions to Mars and energy and systems, we have a question from David Rodriguez, which is, how will Earth-moving equipment such as bulldozers, excavators, dump trucks be delivered to Mars?
You need big rockets.
Like Starship coming up? Is that kind of rocket?
We know of a big rocket right now that's working, and that's the SLS. Mm-hmm. And that can carry an enormous amount of material. So we got to have them. We got to have a set from the small to the large, And it's great that we now have choices coming up. If Starship pans out and it has the opportunity to fill a niche, then that's what we want. But right now, the SLS is working. I mean, they're literally building the second Artemis SLS right now. Artemis 2 SLS is under construction right now. So we're lucky that we have such a powerful capability. And it's more powerful than the Saturn V. And it fits in a new class. The Starship is welcome. They'll each have jobs that they'll be able to do and do well.
Yeah, are you excited about? Are you going to be tuning in for the Starship launch scheduled originally for yesterday, but being pushed to Thursday? You going to be tuning in?
Well, if the time ends up being convenient, yeah.
Sure. Yeah.
If not, it will happen, and I'll read about it. But it doesn't mean I'm not excited about it. Indeed, I am. I'm wishing that'll be successful, and that we now have a new tool in our arsenal.
Yeah, I was curious about your thoughts on the partnership between NASA and SpaceX specifically. I think I mentioned this earlier that I was just at Kennedy Space Center, and I saw the big Blue Origin buildings while I was down there. So not just SpaceX, but Blue Origin as well.
Sure.
But what are your thoughts on that partnership? How critical is it to have?
It's very critical. Yeah. I was at NASA headquarters when the plans were emerging that we really needed to spark a lot more of the commercial activity. We were getting into the era where we were learning a lot about how to work in low Earth orbit. We wanted to go to the moon and then on to Mars. NASA needs to turn over that area into more commercial activities, and it can't just happen overnight. You got to make investments. So NASA indeed was putting money into these, like crazy, and indeed they're just tremendously successful, and that's really great news because we do like competition. I see one of the comments about the SLS being expensive. Yeah, it's expensive. Does that mean everyone will be expensive? Well, it depends on how often it's used. If you have an infrastructure and you then have several groups working, then that lowers the price. Is the SLS unique? Yes, it is the only one right now working that can really put out heavy lift vehicles, and go places. Do we want what are some of the places we want to go? Well, the heliophysicists want to go to the nearest star. Okay, so does the astrophysicist. How are we going to do that? Well, you need something that's really huge to kick it off with a gravity assist at the sun and end up going, 50, 60 kilometers per second, at enormous speeds. And that's the only way you're going to be able to make it far. So all that, you just have to, figure out, is it worth it? Do we really want to do it? And gee, that sounds so expensive. For crying out loud, we just did a James Webb Space Telescope at $10 billion. And look at the fantastic things it's doing. And, I want astrophysics to have even better tools. Well, how are we going to do that? We need bigger rockets, and so I think both Starship and the SLS have futures, and let's embrace them and give them the things that they do best. Because that is revolution scientifically that we want to bring in and live.
Absolutely. I can hear the passion and the enthusiasm behind it. And I love that. I love that you're excited about it. And yeah, I think that you're right. It is expensive, but it has to be. And having those partnerships with those commercial companies, although it is still expensive, eventually is going to help bring down the cost.
Absolutely.
By reusing the rockets, the sustainability, it will eventually.
Absolutely. Yeah. Let's see how all this plays out. Okay. It's not, let's put all our money in this and forget about the rest. This is competition at its best. Okay. Mm-hmm. and let's see, let's give it the chance that it deserves. So there's room to grow in that area, even though the SLS is up and running. Let's see what Starship can do. I want it to be successful.
Absolutely. Well, I agree with you there. Let's see. I've got two other questions that I want to make sure we get asked that came from the listeners. One is, finding local water must be a high priority. Do you have an opinion regarding water recovery from mineral deposits like sulfates? And this is from Kevin.
Yeah, I do. I think it's far easier to get it out of the ice. And as I mentioned, on Mars, there's a huge North Polar Cap that's been buried, an ancient polar cap that we can get to. And it's right now sitting at mid-latitudes. So one thing I did in 2015 is we had a workshop. I helped organize a workshop on bringing scientists and engineers on the human spaceflight side together to pick a site on Mars to go to. Okay. And so that workshop was held at LPI, fabulous workshop. And out of that, the teams came in and were presenting why their site was the best one to be at. And indeed, we had like 50 sites or so that we talked about. And then what we did is we realized we needed more information. So that enabled us to task the Mars Reconnaissance Orbiter to get data for each of these sites, additional data. Now, the high-resolution imaging from the Mars Reconnaissance Orbiter, can't do the whole surface. It's only done 4 or 5% of the surface, and it's been orbiting Mars since 2006. Well, Mars is a big place, and and if you want to get a meter resolution on the ground, it's going to take a long time. And so this is why we did this workshop, is to really figure out where these sites are. Now, NASA's approach to Mars is, of course, creating an exploration zone. Once we decide on that location, we'll go to that location for decades, over and over and over again. It won't be like the Martian, where we'll go to Ares 1, Ares 2, Ares 3, etc. Mm-hmm. We'll have the Mars exploration zone, and it'll be a 200-kilometer area. We'll land in one spot, we'll live in another spot, we'll do ISRU, but it'll be also scientifically rich. Mm-hmm. And so that site has to be found, and that has to be determined. But we've got, nearly 50 sites to consider right now. So the next workshop hopefully will be in another year or so, when all that data is in, and then we can whittle it down to maybe the top 10. All right. And then study those in more detail. So we'll see how that evolves.
Yeah. Well, speaking of sending humans to Mars and picking those locations, I have another question from David. The question is, should we just wait until NTP is developed before sending humans to Mars?
Nah. No.
Nah.
No. So Curiosity has a dosimeter on it. And Curiosity, went all the way to Mars, landed, roved on Mars. We've analyzed that data. We know the environment is a tough environment, and indeed produces risks. And in fact, the analysis seems to indicate that instead of a 3% chance of cancer, you might get a 5% chance of cancer on a similar trajectory during a similar time for astronauts. So I can guarantee, if I walked in the JSC in their Monday morning briefing room where all the astronauts are there, and I can say, the risk for cancer on a route like this during this type of solar conditions, it goes from 3 to 5%. How many want to go? Every hand in the room would still go up. I mean, that's one thing. The other thing is enormous medical advantages are being created. I would recommend that your listeners read a book. It's called The Next 500 Years. It's by Chris Mason, and he talks about the evolution of medicine as it relates to space medicine, and all the techniques that are coming about that can be employed, for gene repair and gene expression and repair of the DNA and all the stuff that are known hazards for radiation in space. Fabulous book. It's absolutely fabulous book.
All right, it's going on my to read list.
Yeah, you should read it. Chris Mason was brought on by NASA to study the twins data. So the first chapter or two of the book is all about the top things that were found in the twin study. And so that turns out to be a fabulous set of information that then is the springboard for the rest of the book. And Chris does a fabulous job talking about the investments that are being made and the advances that are being made. And the humans that will go to Mars will be genetically engineered to be able to make the trip, live and work on that planetary surface for a couple-year trip. And that's what we're moving towards. And we can do it. Read the book.
All right. Well, I'll report back after
do so. Actually, you should have Chris Mason on.
Okay.
And having talk about the book. If you want, I've got his email. I'll give it to you.
All right, there we go, Michael. I know you're listening, so that's going to be on our next up list.
Yeah, right.
Well, I know we're coming up on time, and I wanted to make sure that I asked you. After 42 years at NASA, now you're retired, and you've got a few other projects you're working on. What's next for you? Can you talk a little bit about
sure.
your other projects? Are you going to write a book?
Oh yeah,
that will also be on my to-read list.
Yes, I actually plan on writing a book about my NASA experience. I have quite a bit of stuff to talk about, all the way from my experiences in the neutral buoyancy tank at Marshall Space Flight Center when I made 150 dives, to the missions I've been involved in. I've been involved in probably more than 24 missions from various aspects, from not only the instrument aspect as a instrument co-investigator, but as a deputy project scientist, and certainly as head of a planetary science division at headquarters, constructing and creating a new strategic mission, selling it to the administrator, selling it to NASA, getting it approved by the president and OMB, the Office of Business and Management, or Management and Business, and then going to Congress and presenting the advantages and eventually getting the money for that. And that includes Percy, that includes Clipper, that includes DART. Those are the kind of things that I did for 12 years as head of the Planetary Science Division. So those are fabulous experiences that I need to indeed talk about in my memoirs.
Well, I can't wait. I'm going to pre-order.
Okay.
We'll do a signed version if we can keep.
Yeah, I'll show up at the Mars Society and if Nichelle Nichols can do it, I can do it for at least 2 hours. If the line goes out the door, that'll be great. I would love it.
There we go. Well, Michael and James, I know again you're listening. We've got somebody ready for the Mars Society convention. We're gonna have Jim come there. Well, Jim, I know we're right at time. I just have to say a major thank you so much for coming on today's episode and sharing your experience and your knowledge. This was a wonderful conversation. Again, so many other things I wanted to ask you after your 42 years of experience. I mean, just incredible what you've been able to do.
I have seen it all. I have seen and experienced it all.
Well, I can't wait to read about it in your book. As soon as that's out.
Right. And now I'm teaching space in the metaverse. So I've already developed a series of courses. I have an avatar. I go in and we have three-dimensional models of perseverance and ingenuity. The students walk around. I can tell them, what each of these things do, why they're doing it, and coring rock and bringing the rock back, and why that's so important in terms of understanding potential life on Mars. But certainly it's evolution over time, geologically and even atmospheric aspects that can be done. So teaching in the metaverse has just really been fantastic. So if you got an Oculus,
sign up.
You sign up. Yeah, walk into my classroom one of these days and enjoy it.
You're going to see an influx of registrants now.
That'd be good. That'd be good.
Absolutely. Well, thank you again so much. I really appreciate your time. A special thank you to Michael Stoltz, to James Burke, our friends at Liftport. Thank you so much for all your help today. And thank you, listeners. You had excellent questions. This was an engaging conversation. So thank you for everybody's participation. Thank you, everybody. And as you always hear me say, the best is yet to come. Have a great day, everybody.
Bye now.